Hey guys, welcome back to another LeetCode tutorial. In this video, we are looking at problem number 141, that is linked list cycle. You are given the head of a linked list as a parameter, and then we need to determine if the linked list has a cycle or not. To understand what a cycle means, here it says that there is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. We all know that a singly linked list is a unidirectional. That is, you go from one node to another node until you hit the null pointer. But if you hit a node twice, that means there is a cycle within the linked list. There is no other way you can visit a node twice in a singly linked list because it's unidirectional. And then if you are visiting it again, you ought to have a cycle in the linked list. Okay, so let me use a drawing board here to help you understand this better. So as you can see, we have our pointer head pointing to the first node of the linked list, that is the head of the linked list. So the traversal of the linked list always goes from node to node. So from one pointer to another pointer, from here to here, here to here, here to here. So if it is a regular linked list without any cycle, then you would, so example, just just imagine that this is not there. Okay, so first and foremost thing is we are going to go through each of these lists, each of these nodes, and then you are eventually going to hit the null pointer, and then that will be the end of it. But if you have a cycle within this linked list, that means you're going to come here, and then go all the way till the end of the linked list, and then again go back to this. So in this case, you are visiting the node 3 with a value 3 twice. So that means there is a cycle. So whenever you're visiting this twice, there is a cycle. So let's go this step by step. We are at 1, right, which is the head of the linked list. So you are going to say true. So you have visited the node. Now you're going to do a head dot next. Here you've already visited, so you're going to move to the next node, which is node with a value 2, and then you are going to check if node has been visited before. No, so you're going to update this to true. Similarly, you're going to do a head dot next again on this. At this point, you're going to check if 3 has been visited or not. 3 is, there's no record for 3, so you're going to update this 3 to true. So you're visiting this. Again, you go to 4. You're going to check if 4 has a mapping. There is no mapping for 4, so you're going to add 4 to this. 4 and true. So this is a map on the right hand side. And now I'm going to go to the 5 and then check if 5 has true or not. It doesn't have true. So I'm going to add 5 to this map and set it to true. Now again, I'm going to do a head dot next. This time I'm going to go back to 3 because of a cycle that we have. In that particular case, I'm going to check again if 3 has a mapping. 3 already has a mapping within this map. So that means I'm just going to return true because I have visited this node before. So by using a map, I can tell that I have visited this node. So we are essentially using extra space with with a space of O of n, that is n being the number of nodes within the linked list, the maximum number of nodes within the linked list. So that is how we can determine if a particular linked list has a cycle or not. But there is a follow-up to this question, which says, can you solve it using O of n, that is constant memory? In that case, we are not allowed to use a map. To solve this without using any extra space, we are going to be looking at something called as Floyd's cycle detection algorithm. Okay, here we are going to make use of the head that is given to us in the program, and then we are going to assign two different variables but point them to the same head here. Head. So if you see, I have two pointers, fast and slow. I've declared them, and then they point to the head node of the linked list. Okay. Now, while traversing through the linked list, there is a peculiar behavior of how these pointers move. The red one, which is being the fast pointer, is not going to move just one step, but it's going to move to two nodes at a time. Okay, so that's why it's going to say f dot next dot next, and the slow pointer is only going to move one step at a time. Okay, so you can compare this with a hare and a tortoise. So hare being the faster pointer and the slower one being the tortoise. Okay, all right. Next, let's start off with traversing through the linked list. First, they start off on the same node. Now the slow pointer moves one step, and the fast pointer moves two steps. And every time we perform these two steps, when I say two steps, the pointer is being moved, the slow pointer and the fast pointer, after they move, we are going to make a check whether the slow pointer and the fast pointer are pointing to the same node or not. In this case, they clearly do not point to the same node. Slow pointer is pointing to the node with a value 2, and the fast pointer is pointing to a node with a value 3. Now I'm going to move my slow pointer again. So I'm going to move it to 3, and this is going to move two steps, and then the fast pointer moves further away from the slow pointer. In that case, we have something called, we are going to make another check. There we are going to check if fast pointer and slow pointer are pointing to the same nodes. That's not the case. Then I'm going to just continue, and then I'm going to move my slow pointer again. My fast pointer is going to go through the cycle, come here, and then move one more step because it needs to move two steps, remember? So it's going to come here and then move one more time. Now we are going to make a check whether the fast pointer is pointing to the slow pointer. In this case, they are pointing to the same node. That means there is a cycle within this linked list. Otherwise, there is no way a slow pointer would be able to catch up with the fast pointer because it's moving two steps at a time, whereas the slow pointer is moving one step at a time. So if they arrive on a same node after starting from the head in on any particular iteration, that means there is a cycle within this linked list. Now that is the logic that we are going to use to determine if there is a cycle in a linked list without using any extra memory. Okay, I hope this explanation is clear to you guys. So I'm going to start writing the solution for this here. So the first and foremost thing that I am going to do here is, if the head is null, right, I'm going to return false, because if there is empty linked list, there is no chance of having a cycle there. Okay, and then after making that base check, I'm going to do I'm going to declare two pointers. One is the slow pointer, which is pointing to the head, and the other one is a fast pointer, which is also pointing to the same head. All right, now that I have my two variables set and pointing to the head, I'm going to come up with a while loop to traverse through the linked list. And the logic that I'm going to use here is, since my fast pointer is the one that moves faster than the slow, if there is no cycle, this is going to hit the end of the linked list quicker than the slow pointer. So that means I'm it might hit the null pointer, or it might hit the one which is the last node of the linked list before the null pointer. So either ways, I'm going to check if the fast pointer exists in the first place, or if my fast pointer dot next exists, right? In that case, so if fast pointer exists is basically to check it has not hit the null pointer, or the fast dot next check is basically to check if the fast pointer ended up on the last node and it cannot move any further, because a fast pointer is always going to move two steps at a time. So if it is on the last node, fast.next.next doesn't really exist. So as long as it reaches the null directly or it reaches the last node, I'm going to continue doing these operations, where I'm going to say slow is equal to slow.next and fast is equal to fast dot next dot next. If I do not have this condition here, then it's going to fail. My program is going to crash because if fast dot next is null, I cannot perform a dot next on it. That's why it's important to have this condition here. Okay. Now the check that I'm going to make here is I'm going to check if slow pointer or a slow head. I mean the pointer which is pointing to the node which is slow, and the pointer which is pointing to the node head, uh, not head, sorry, it's fast. If they are equal, so if they point to the same node, then I'm going to return true, right? Because this is only possible if there is a cycle. If I hit the end of the while loop, then I'm just going to say return false. There is no cycle that we could find in this linked list. So that is the basic logic of finding whether we have a cycle within the linked list or not. Let me just go ahead and run this. As you can see, it has passed for all of our test cases. I'll go ahead and submit this. As you can see, our solution has been accepted, and this is how you determine if a linked list has a cycle or not. I hope this explanation is clear to you guys and it has added some value to you. If yes, please like this video and consider subscribing to my channel. And thank you so much for watching, and I'll see you in the next one.